Okay, how's everybody today?
Okay.
Okay, good, good, good. Okay, so our plan today is we are going to go ahead and start logarithms. I'm going to introduce you to what they are and how we work with them. So they're one of those concepts where they sound worse than they really are. It's going to be, it's going to be fine. Let's see. So today we're going to talk about logarithms. We're going to continue that into tomorrow. The exponential equations assignment is going to be due, and I did pass that out, correct? Yes, okay, I thought so. So we'll talk about that tomorrow. We'll kind of use that as a little review. We'll have our exponential equations quiz tomorrow, and we should be able to finish up the week with logarithms. We may or may not go ahead and talk about properties. We'll kind of see how that happens. But that's our plan, unless anybody has any questions.
What about the quiz tomorrow?
Mhm.
Is over like power stuff like
Yes. So like if we had if we had the same base, like maybe 2 to the 3x plus 4 is equal to 2 to the fifth. Okay. Mhm. Or if we had something like, oh, I don't know, 3 to the 2x equals 9 to the 5x minus 1. So those are the types of problems where if you're not given the same base, you got to rewrite one or possibly both. But that's the quiz. That's exactly right. Okay. Well, good, 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 good. Well, let's see what we've got here. We are going to go ahead and start talking about logarithms. So if everybody's ready, we're going to go ahead and log on.
all
I got jokes this week. Okay. All right. So what is a logarithm? A logarithm, or as we abbreviate a log, is another way of writing exponents. Okay. Now we did a lesson last week over inverses, so we're going to come to find out that exponentials and logarithms, they're inverses of each other. Everything we know about exponentials, if I reverse the ideas, we're going to end up with a logarithm. Now, the easiest way that I could go ahead and describe a logarithm is in one word. It's a power. That is exactly what a logarithm is. Any log statement that you ever write, it has to equal the power that's placed on the base in order to get what we call the argument. Now, whether you're dealing with logarithmic form or exponential form, there are three parts, okay? They got the same three parts. We have the base, we have the power or the exponent, and we have what's called the argument. So I've shown you these in both of these. So for this first one, logarithmic form, we read it as log base b of a. So a couple things I want to point out when it comes to a logarithm. This b right here is a subscript, okay? But you want to say the word base prior to whatever the base is. So you'll say log base, whatever that may be, of. Whatever's in parentheses, now this one doesn't have it, I'll go ahead and throw those in there. But whatever's in parentheses for the logarithm, that's what we refer to as the argument. Super, super important. That A is not a power on B. They're just two different parts of the notation that we're writing. Okay. And then, of course, whatever the log equals, that's the power. Okay. Whenever you're looking at the exponential, it's going to be really easy to identify two of the three. The base is what carries the power. Okay, the power is going to dictate how many times the base is multiplied against itself. Okay, we know that. So the third item has to be the argument. Okay. So what we want to go ahead and do first off is go ahead and just practice converting from a log to an exponential and then back again. Okay, so let's start with number one here. Okay, log base 3 of 9 equals 2. Okay, notice how I did say base 3 and then of prior to saying the argument. So 3 is my base, 9 is the argument, 2 is my power. Okay, so what you can do here is start with the base and kind of just put a circle through your notation here. So you start with the base 3, raise it to the power 2, and then you set it equal to your argument. So log base 3 of 9 equals 2 because 3 to the power of 2 equals 9. And that's a true statement. 3 squared equals 9. Took me a second to see what you want me to look at. Okay. But that's why I went ahead in the very first here just said that a log is a power. Whatever log statement you write, it has to equal the power that's placed on your base in order to get the argument. It's inside the logarithm, the parentheses. Okay. Now, I know you're probably wondering, well, why do we even have this? Knowing about logarithms makes solving certain types of equations so much easier. Okay. Well, let's try number 2. How would I read this? Log what? Okay. Log base 6 of 216 equals 3. So I've got my base. Okay. I've got the power. And what's inside, that's my argument. Remember, there's always 3 parts to a log or an exponential. Okay. So log base 6 of 216 equals 3. So my exponential would be base 6 to the 3rd power equals 216. There we go. See, once you get the idea, it's going to start to go super quick. Okay. Any questions so far? 6 times 6 times 6 is 216. Let's see how you typed it down. Well, you've got this icon here. I don't know. That's
Let me just do.
no, that's true. And I can even pull up the calculator real fast and show you 6 cubed is 216. There's got to be something in the settings or something. Okay. All right, well, let's take a look at number 3. How would I read this? Log base 7 of 1 equals 0. Okay, right. What would the exponential form be? There you go. That's all there is to it. It is true, yeah. Every one of these are going to be true. Okay. So 7 to the 0 power equals 1. Okay. Number 4, how would I read that? Log base 2 of 16 equals 4. Bobby, can you tell me the equivalent exponential? There you go. You just kind of curve your way through the log notation. That's all there is to it. Okay. Let's try number 5. How do I say that? Log base 4. There we go. Okay. Let's see here. Jackson, what would that exponential be? Okay. Remember, we always start with the base. So what's our base? 4. So that takes care of that one. There's only 2 left. Which one's my power? Okay. The log always equals the power. So you raise your base to your power. And then we're going to set it equal to 1/16. And see, this makes sense because think back to your exponent rules. How do you make a negative power positive? By taking the reciprocal, by flipping it. Yeah, so 4 to the negative 2 would be 1 over 4 to the positive 2. And see, that's how we get our 1/16. Okay? This is just simply taking an exponential and it's rewriting it in a different way. That's what a log is. Okay? Last one here, number 6. How would I read that? So log base 9 of 27 equals 3 halves. Okay? May, what would the exponential be? There you go. That's exactly right. Okay. Converting between the two is super easy. This is from a log to an exponential. Okay, so are there any questions on that? Okay. Well, now what we're going to do is reverse that process. Okay, I'm going to give you an exponential, and then you're going to go ahead and tell me what the corresponding log statement is. Yeah, we still have the same 3 parts. So number 7, 14 squared equals 196. Okay, so 14 is my base. Okay, what's 2? That's my power. So that means 196 is my what? argument. Well, once you already have the terms identified, well, saying log base something, you already know what the base is. So I'm going to go ahead and write the word log. Base what? Base 14. Okay, so that takes care of the 14 of what? Of 196 equals 2. Now remember, no matter what, every single time you write a log expression, it must equal the power. So whatever your exponent is, that's what your log has to equal, because that's what a log is. It is simply a power. Log base 14 of 196 equals 2. Now, you don't have to go ahead and put the parentheses. I always got in the habit of doing so because I like to see exactly what it is I'm working with. And the calculator does that anyway. Yeah, you're exactly right. Okay, so let's try number 8. 3 to the 4th power equals 81. Sarvesh, what would this one be? So log base 3, so I'm going to write that as a subscript, of 81. And what should that equal? 4. It should equal 4 because 4 is your power. That's it. That's all there is to it. Okay? Because once you understand the conversion process, when we start to simplify these, it's going to go a lot easier because you're thinking about what power do I put on the base to get this argument. Okay. Well, let's try number 9. I got 12 to the 1st equals 12. Okay. Sada, what would that be as a log? Okay. Well, if you say log 12, I got to do this. The tiny number, so what do we say right before it starts with a B? Base. So log base 12 of, and it must equal 1. There you go. The log has to equal 1 because the log is a power. Okay. See how easy is this, right? Easy as falling off a log. Okay, now let me ask you a question real fast. I did that same joke because we're currently talking about logarithms in my AP pre-calc class. So I made that. It's an old saying that I remember hearing forever. You folks have heard that, right? Easy as falling off a log? You've never heard that saying? Oh. What about its bark is worse than its bite? That one you've heard, okay, because we're working with logs. Okay. What I really don't want to happen is make sure that logs stump anybody. Well, they're all fun. Yeah. Okay, I got you. Okay. So number 10. Okay, 36 to the 1/2 equals 6. Okay. Ariana, what would that be as a log? Log base 36 of 6 equals 1/2. That's all there is to it. Okay. Once you figure out the 3 terms and the pattern, it goes so quick. Okay. Let's try number 11. 2 to the negative 3 equals 1/8. Okay. Ridley, will you help me out with this one? Log base 2. There you go. Even if that power is negative, it makes no difference. Okay, the log is a power. That's what it has to equal. Okay. And let's try this last one, number 12. 8 to the 4/3 power equals 16. Dana, can you finish that up for me? So log 8. Remember, what word do we have to say? Starts with a B. Base. Okay, so log base 8 of 16. There you go. That is it. Okay. Has anybody had any previous experience with logs? Oh, yeah? Okay, good. Okay. In the woods? Oh, yeah? I am so excited. I just got confirmation last night that you have a tree in your front yard, so do I. I got confirmation last night because it was up in the air. I am going to have the opportunity to go fly fishing this summer. Fly fishing is where you imitate the hatching and movements of different kind of insects or larvae to entice the fish. It's not bait fishing. It's amazing. Oh, yeah, it really is. It's so cool. And I'm excited because I'm going to be out in the middle of the woods, no cell phones. I'm going to be looking at a tree. I'm going to think there's a log, you know, and then I'm going to come across an actual log. And then I'm going to try to tell my kids what a log is. They're not going to listen to me, you know. But yeah. Anyway. What'd you say? Occasionally, but a lot of times they like to leave me alone. But I mean, sometimes they try harder. They stick to it. But, I'm on fire today. There we go. Oh, there we go. We're going to get to the root of that problem. Oh. Okay. we, we went pretty far. Okay. Common logarithm. So a log with base 10 is a common logarithm and can be written without the base. Okay, so this is only one of two bases that we actually don't have to write. So if you see something log base 10 of x, you can write it like this and it's perfectly fine. Log of x. Okay, that's the only time you don't have to say base. Okay, so if you don't see a base when you have the word log, it's automatically base 10. We call that the common log. Now, these resources are kind of out of date because back when I was in high school and I was learning this material, for the first time, we didn't have the inspires that you folks now do. So we only had two options. You could either evaluate a log as a common log, or you could evaluate it using the natural number e. Those are the only two options. But once we go ahead and start getting these on the calculator, you're going to see that you can do whatever you want. I mean, there's already places for you to plug these in. You just got to know the keystrokes. But I'm getting a little ahead of myself. Well, it's a value like pi. So it's 2.718. And the reason we refer to it as the natural number, it's not a number that we actually engineered or created ourselves. It is actually a value that we find in nature. It's actually really cool. It's part of, yes. 2.718, and then it keeps going. Yeah, in its own way. Yeah. Mm-hmm. Okay, so let's take a look at evaluating logarithms. Okay, use your knowledge of exponents to evaluate the following logarithms. Now, here's the thing. We're going to go ahead and start out, and I'm going to go ahead and turn these into equations. But eventually, I'm hoping you're going to go ahead and get to the point where you see an expression like this, you'll be able to go ahead and tell me what the value is. Like, let me show you what I mean. Number 13. So log base 7 of 9, or 49. So we have the base, we have the argument, but we don't know the power that it equals. So some of these you might be able to tell immediately, right away. So let's go ahead. Yes. Now, if you're not able to see it, we can convert it to an exponential, and that does go a long way in helping a lot of students kind of realize what the value is. So we're going to take base 7 to the power x equals 49. We're going to convert it back to an exponential just like we had a moment ago. So think about it. 7 to what power is 49? X is 2. Okay. So that's why log base 7 of 49, it's 2. Remember, that's all a logarithm is. What you're trying to find here is the power, the exponent. What power will I put on the base in order to get that argument? That is exactly what a logarithm is. Okay. Now, would you like me to go ahead and continue putting each of these equal to x and converting them? Or do you just want to try telling me the number? Only with the hard ones? So let's do at least a couple more while we'll convert them. Okay. So let's say log base 3 of 27. I don't know what that is. So what would this be as an exponential? So base 3 to the power x equals 27. So 3 to what power would give me 27? X equals 3. So let me write x. Okay. So why does log base 3 of 27 equal 3? Well, because 3 to the third power gives me the argument. That's what I'm trying to find is what's inside the log. We refer to that as the argument. Okay. Now, on 15, I think I'm a little confused. There's no base. There we go. If no base is given, we automatically know that's base 10. This is the common log. Okay. So let's see here. 10 raised to what power is 100? 2. 10 squared, 10 times 10 is 100. Okay. Now remember, if it is a little difficult, you can go ahead and set it equal to x, and you can convert it if that helps you kind of see it a little better. Okay. Let's try 16. Log base 12 of 1. Now maybe on this one, let's go ahead and say it equals x. Okay. What's the exponential? Okay. So 12 to the x power would equal 1. So this is one of my exponent rules. Anything to the 0 power will always result in 1. Okay. Is there anybody who's confused by this? Anybody having a hard time? Okay. We're doing good? Okay. Cool, 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 cool. All right. What about 17? Log base 2 of 64. Well, now 2 squared will give me 4, so we're not quite there. There we go. So 2 to the power x would give me 64. Well, it takes the power of 6. Because 2 times 2 times 2 times 2 times 2 times 2.
Wait, pi is equal to 3.15 because when we like
No.
trying to like
3.14.
Well, even if you wanted to look at the following digits, it still wouldn't be enough to round it. So 3.14159265358979932384626436264333. It's great at parties. I'm super popular. All right, let's try number 18. Log base 3 of 243. So basically, we're asking ourselves 3 raised to what power is 243? Okay, 3 to the 5th? Not quite. Oh, I'm sorry, I was looking at the wrong answer. Yes. 3 to the 5th. Blech. I was just messing around to see if y'all were paying attention. And obviously you were. Okay. All right. Number 19, we got log base 9 of 181st. Okay. Now, this one, let's go ahead and take a look at the exponential. So 9 to some power, I got to go from a whole number to a fractional value. What do you think that's telling me about my power? It has to be negative. Okay, because remember, in order to get that fraction, the negative, we got to take the reciprocal. So 9 to what power is 81? 2. So it would have to be negative 2. Because 9 to the negative 2, I'm going to go ahead and flip it. See, that's how I get the 181st. Okay. All right. And number 20, log base 64 of 4. Okay. So let's say it's x. So 64 to the x power is equal to 4. Okay. There we go. Now, on this one, if you have to, if you're not able to tell, yeah, we're going from a larger whole number to a smaller, so I'm thinking there has to be some kind of fractional power here. Okay. So as you work through these, you're going to start to become more, better at figuring out what your value is going to have to be. But we know the answer is going to be 1/3. But think about what we were doing the past couple of days when we were solving exponential equations. That's exactly what this is. If it gets a little tough and you can't figure out what your power, the answer has to be, well, let's do this. What do 4 and 64 share? They share 4. Okay, so I'm going to leave this 4 as is, but 4 to what power is going to give me 64? 4 cubed. Okay. Now we're going to use the power of a power, so this would be 4 to the 3x power equals 4 to the first. See, once I have the same base, I can ignore those. See, this is exactly what we were doing earlier in the week. So if 3x equals 1, we're still getting 1/3. Oh, yeah, well, that'll work too. Here we go. Okay. So see, if you do get stuck, you can go ahead and change one or both of the bases to help you out. Okay. But I think the more of these that you work with, you're going to become familiar with the numbers you see, and it's going to start to get a lot easier. Okay. And here's our last section today, the change of base formula. Okay, some logarithms are not as easy to evaluate as those above, and they'll require what we call the change of base formula. Okay, so here's how this works. If I have log base b of a, okay, what I can do is I can choose any base that I want. Now, there are two restrictions. This one here tells you to go ahead and use the common log, which we'll go ahead and do for a while, but I'm going to show you something. Whatever base you choose, it has to be positive, and the base cannot equal 1. Okay? As long as you're choosing a base that is not negative, cannot be 1, you're going to get the same answer every single time. Now, let me show you what the change of base actually does. The argument a, that remains the argument in your numerator. The original base, that becomes the argument in your denominator. And then you just go ahead and plug in whatever base you want. Now here, they're really encouraging you to go ahead and use the common log. Okay, so let's take a look at this one. Let's say log base 16 of 64. Okay, so this is my b right here. This is the base. Okay, this is the a and the formula right here. So I'm going to go ahead and set up a fraction. I'm going to say log base 10 of 64. What do you think's going in the bottom? Okay, log base 10 of 16. Okay, remember the original argument that goes in the numerator. The original base that becomes the argument in your denominator. Oh, mm-hmm. Okay, so let me show you this. Now, we actually don't have to do this with the Inspires that we had. You know, back in the day when all we had was the 84s, you know, okay? We had to go ahead and do this, but let me show you how to plug this in the calculator. Let's say log base 16 of 64. So I'm going to come on over here to my calculator. So here's what you do. You're going to hit your control button over on the left side, and then right next to 1, you see this button that says 10 to the x? That's your log. Well, see, it not only provides you a base, but it also provides you a space for your argument. So all I have to do is type in, okay, I've got a base of 16. I got an argument of 64. There's my answer. Okay. Yeah, now let me show you. Let's plug in the change of base that we just did. So I'm going to hit Control Divide, a big fraction. So I'm going to put a log both in the top and in the bottom. Okay. Now remember, our base is what? We're changing it to 10. Up top, we had 64. Down below, we had 16. Okay, we're simply using the change of base to rewrite it as base 10. Watch what's going to happen. Okay. Now, you want to see something that's really, really cool? Of course you do. Okay, so we're going to stick with this for the time being. Log base 16 of 64. Give me any number as long as it's positive and not equal to 1. Let's do 2. Okay, we can do 7. So let's do 2. First off, rewrite this with base 2. Okay, don't say it out loud. Let's see if everybody can do it. So it's going to be a big fraction. Okay, you're going to have a log up top. Remember, this change of base formula will work with any base as long as it's positive and not 1. Okay. Everybody ready? So you chose base 2. So I'm going to put base 2, but we still have the same arguments. So it should be log base 2 of 64 divided by log base 2 of 16. Now, let's come on over here to the calculator. Let's test that. Let's plug this in. Okay, I'm going to put a log both above and below. We're choosing base 2. Okay, and we had a 64 up top. We had the 16 down below. Okay, every single time. Let's do it. Okay, so let's go ahead and change these. You said log base 1,728. It does not matter. As long as it's positive and not equal to 1, this works every single time. Then you got a problem. Well, they're not defined, and there's reasons for that. We may or may not be able to get into them. I mean, when we start getting into the properties, if anybody would like me to prove those, I could do that. But we really haven't done that a whole lot in this class. So I'll just give you the rule. Okay. Okay. So let's go ahead. Let's try this next one out here. So log base 8 of 32, and then I'm going to go ahead and show you something on this. Okay. Log base 8 of 32. Okay, well, rewrite this using base 10. Rewrite this using base 10. Oh, don't say it yet. Don't say it yet. I want to give everybody the opportunity. Okay, so we want to take log base 8 of 32, and we want to use the change of base formula to rewrite it base 10. Okay. So here's what we should be getting. Log base 10 of what? 32 divided by log base 10 of 8. Remember, the original argument goes in the numerator. The original base goes in the denominator. Okay. Now, you could have also written it like this. Just log of 32 divided by log of 8. Because it's the common log. Base 10 is the only base we don't have to write if we don't want to. Okay, so check this out. When I come back over here to the calculator, let me go ahead and erase all this. Okay, control divide. Okay, let me go ahead and put some logs in here. Okay, now in the calculator, when you're working with base 10, you don't even have to type in base 10. If I go ahead and leave the base blank, the calculator will automatically take it as base 10. So we had what, 32 and 8? Okay. Now, if I want to put in the 10s, I can. I'm going to leave them out this time. Boom. It's going to give my answer. Okay. It depends on your settings. Yes. In fact, give me another number. 7. So let's change base, log base 8 of 32 with base 7. So I'm going to change this to 7, change this one to 7. Every time. Every time. Okay. There we go. As long as it's, what, 2 conditions? Has to be positive, cannot equal 1. Beyond that, I could put pi in there, and it would work. Okay, does anybody want to see it? So let's see it. Okay, so let me go ahead and take out this 7. I'm going to use this pi and friends button down here. Oh, it took out that. That was interesting. I don't know why I did that. Why is it doing that? Yeah, it's going to work, but I don't know. The calculator's acting all weird. Okay, let me go ahead and try this again. Put in log, put in log. Okay, so for this one, I want to put in pi. Okay, for this one, I want to put in pi. Okay, then it was 32 and 8. Okay. Now that will be an issue. It's got to be the same base. There you go. So what are we thinking about our first discussion of logs? Okay, it's one of those things, where you hear logarithm, you start to have a little bit of anxiety because you're like, I have no idea what that is. But it's one of those things where it's definitely easier to work with than you think. Okay. All right. Well, I'll tell you what, we've made it far enough today. I'd say that's good.